Okay, let's see how we're doing. Find the measure angle ACB. Brianna, did you get that measure? Angle ACB. What would that measure be? Not sure? Okay, so trace it. So ACB, and it's the middle one, right where that vertex at C is. Okay, so that would be 56 degrees. Oopsie, I don't know why I squared it. Okay. Next one. So Rihanna, could you tell me what CBD would be then? Good. CBD then is right here at 82 degrees. Jenny, can you tell me ABC? 45. ABC then is 45. And who finally has angle DCB? Or DCA, sorry. Yep. Very good. DCA is this whole thing, so it'd have to be the 56 plus the 38, which was 94 degrees. Any questions over that? So again, just helping us remember how to label an angle. Okay, so if you're struggling with that, just trace it and see the middle. Okay, the next one is asking about parallel and perpendicular lines, and I just want to make sure you know what the notation looks like. So we're going to start with that first, this line here. Okay. And we're going to say line AC. When you have writing a line, you put arrows, a line with an arrows over it to show it's a line. It has the parallel mark with this side, with that line. So we say it's parallel to line BD. These again, little marks are my parallel marks. This is how you write parallel. Using geometry notation. Can somebody raise their hand and tell me the other two lines that are parallel? Yep. Very good. AB and CD. So we'd say line AB is parallel to line CD. And then ask us also about perpendicular. So we're going to go back to our AC. And line AC is perpendicular to CD. I know it's perpendicular because it shows a right angle. And the definition of perpendicular lines are two lines that intersect to find to give four right angles. Okay, so all I have to do is show that right angle mark, and I know that those lines are perpendicular. Does that make sense? Okay. Can someone give me another pair? Mm-hmm. Okay, AB, line AB is perpendicular to BD. Very good. Okay, and again, that's your perpendicular mark. So the two lines mean parallel, and the upside down T is a perpendicular sign. Now congruency, we talked about similarity, and congruency and similarity are kind of the same. Congruent means they're all equal, but you use the congruency statement the same. Okay. Brandon, can you name this triangle for me? Triangle what? Use the letters that are involved in it. Okay, ABC. Triangle A, B, C. This is your congruency mark. The equal sign with the little squiggly line over it means congruent. And it's congruent to triangle. Now you have to pair them up. So A goes with what angle on the other triangle, class? D. So D has to go first. Okay, the next one is our B. So B goes with what other angle? F. And then finally, E is going to go with C. So that's your congruency statement. Just like we did with similarity, we'd have to match up the corresponding angles. Any questions over that? Okay. Okay. Now, perpendicular bisector. Okay, that's what we're going to learn right now. The definition of a perpendicular bisector. We need two things to be a perpendicular bisector. Any guesses at what we need? I don't need a triangle necessarily. Yes? I need bisecting. That means cutting things in half. What's the other thing I need? How are they going to intersect? At 90-degree angles. I need a perpendicular, right? That's exactly, it's in the name. Perpendicular bisector means I need to cut it in half and be perpendicular to it, right? Okay, so our perpendicular bisector is a line or a segment that intersects a segment to form perpendicular lines. I wrote that. And remember, that means 4 right angles. And divides the segment into 2 congruent parts. Okay, so a line or a segment that intersects a segment to form perpendicular lines, which means it's 4 right angles, and divides the segment into 2 congruent parts. Okay, so we're going to draw an example of this. I'm going to label this AB. I'll label this CD. So we would say that CD is the perpendicular bisector we should say if CD is the perpendicular bisector, then CD is perpendicular, segment CD is perpendicular to AB. And AP is congruent to segment PB. Any questions over that? Okay, now the perpendicular bisector theorem is any point on the perpendicular bisector of a segment is equal distance from the endpoints. Okay, so now what they're saying is if I put a point on segment CD, so let's put a point somewhere on there, it doesn't matter where, and let's label it M. If I draw the segment to the endpoint and do the same thing on the other side, then I would say that AM is congruent to MB. Okay, that's what equal distance means. They're equal, they're congruent. Okay. So again, we would say if CD, segment CD, is the perpendicular bisector of segment AB, then segment MA will be congruent to segment MB. So this would be congruent to this. And those are my congruency marks. Any questions over that? Okay, now we're going to use it. So tonight's homework is all about proving things. I care about the math slightly, but I care more about why. Why is that correct? So you always want to write down the why. Okay, so if JK is the perpendicular bisector of segment AB, what is congruent and why? Very good. So we're going to say the first thing would be JA is congruent to JB. Segment JA is congruent to segment JB. And the reason why? Yep. Okay. We were going to use this, the perpendicular bisector theorem. That's what we're going to state. Okay, that's the reason why. Okay. And I'm going to abbreviate because that's nice. I'm going to do perpendicular, the sign for perpendicular. Bisector theorem. Perpendicular bisector theorem. There's something else. What else would be congruent if I tell you that those are perpendicular bisectors? Yep. KB and KA. And what's our reasoning? It's a perpendicular bisector, okay? So when we're saying it's what it is, we use the definition of it. Okay, so I'm going to abbreviate that again. I'm going to put the definition of perpendicular bisector, because that's part of the definition, that it cuts the segment into two congruent parts. Now there's a lot of other things I could say in regards to this. Okay, I could say that they have the 4 right angles and they're congruent to each other because right angles are congruent. Okay, but that's all I really care. I want you to be able to use the perpendicular bisector theorem and the definition of perpendicular bisector. Does that make sense? Okay. So now we're going to use it to find x. So MB, line MB, sorry, we're going to find line MB. So they give us the figure, and they want us to find MB and explain why. So any idea on how I'm going to find MB? Yep. Very good. So this should be congruent to this. Okay. You can see that this line LM is the perpendicular bisector of AB because it has a right angle and cuts it into two congruent parts. So that means I can have 3x equal to x plus 20. And our reason why would be the perpendicular bisector theorem. Because the perpendicular bisector theorem says that a point on the perpendicular bisector will be equal distance to the endpoints. Now I'm going to solve that. I'm going to subtract x minus x. That gives me 2x equals 20. Divide by 2, and I get x equals 10. Okay, but it didn't ask me for x. It asked me to find MB. And this is my MB. So I'm going to plug 10 in for x plus 20, because that's what MB equals. And that gives me 30. So MB is 30. Any questions over that? Okay, now they want us to find W. Here's W. Any ideas how I'm going to find W? Pythagorean theorem, right? I should know that this is a right triangle, and I have the hypotenuse, and I have one of the legs. So to find the missing leg, I'm going to use the Pythagorean theorem. So we're going to say Y, Pythagorean theorem. So I'm going to give you 8 squared plus W squared equals 30 squared. Any questions over that? Okay, keep going. 64 plus W squared equals 900. Subtract the 64. Then you get W squared equals 8. Three. 836. Then I'm going to square root it. And I have W equals 28.9. Any questions about? We're good? Okay, on the back. Okay, try to do F in your pairs and find the reason. Okay, so most of you came up with NP is equal to 7 plus 7, which was 14, right? They wanted you to find that whole thing. And that whole thing is those two parts added together, right? Okay, why did I know that NM was 7 and then MP was also 7? How did I know that? Very good. Okay, because I gave you that it was a midpoint, that M was the midpoint. So that first thing to tell me that NP is equal to 7 is the definition of what a midpoint is. Okay, always look at the given information, and if they give you words, okay, I gave you words of a midpoint, or if I give you words of a perpendicular, I'm usually going to use what that definition is. I have to explain what that means. So I'm going to use the definition of whatever that word is. Okay, the next thing I did was I took NP and I added the 7 plus the 7 to get my the whole segment. Okay, and that's the segment addition postulate. Okay, the segment addition postulate states that if I have a big segment and I cut it into parts, the two parts are going to equal the whole. Okay, which I had here. I had two smaller parts and it equal the whole thing. Small plus small equals big. That's kind of a way to remember it. The two pieces, when I add them together, give the big thing. Okay, so you have to justify the steps like this. Any questions over that? Okay, now, angle LMN given, angle LMN is a right angle. So what does that mean? 90-degree angle, right? Okay, so the measure of angle LMN is 90 degrees. And what's our reason why? Anyone want to take a good guess? Definition of a right angle. That's what a definition of right angle, right? I gave you right angle. So it's the definition. Okay, then MP is an angle bisector. So MP is an angle bisector. What does that mean? Okay, it cuts it in half. Okay, so I could say that this angle is congruent to this angle. Does that make sense? Okay. So I could say the measure of angle LMP is equal to the measure of angle PMN. Anyone want to guess at what that reasoning is? PMN, LMP. NMP is the same thing. It doesn't matter which order I put it. Okay. Okay, and what's the reason behind that? Definition, right? Definition of our angle bisector, once again. I gave you words, we're gonna use the definition of it. See, I don't need to write it all out. Definition of angle bisector. Okay, we get seeing how this works? Okay, so now how can I set up my equation? Okay, good. So 2x minus 7 is half of 90, right? And she did it in her head. She just put 45, took half of it. So that gives me 2x minus 7 equals 45. I'm going to add 7 to both sides and get 2x equals 52. Divide by 2, divide by 2, and I get x equals 226. Any questions over that? How are we doing? Okay. Okay, next one's a little tricky. Okay, we're not going to be using definitions here. Okay, given those two triangles, triangle ABC is congruent to triangle PQR. Find x. Okay. So R corresponds to what angle in the other triangle? Very good. You can look here. Here's R. It's the last one in the second triangle. So it has to go to the last one in the first triangle. So C is congruent to R. Okay. So angle C is congruent to angle R. Does anyone remember why? Last year you probably learned this. When you were dealing with congruent triangles last year, you should have learned this other part of it, which was that corresponding angles or corresponding parts in congruent triangles are congruent. CP, CTC, did you guys sound familiar at all? Okay, so that's how it should go. Corresponding parts. Incongruent triangles are congruent. Corresponding parts in congruent triangles are congruent. Once you're given the two triangles, then you can prove that all the other segments and angles are congruent using that. Okay, based on that, now you can say that 3x minus 1 is equal to 71. And then solve. Add 1 to both sides. Get 3x equals 72. Divide by 3, divide by 3. And we get x equals 24. Any questions over that? Okay, so now I want you guys, we're just reviewing our translation, reflection, and rotation. So do those three. Make sure you're seeing that this reflects across the y equals 0 line. And this is where y equals 0. FYI. This is my y equals 0 line, because that's where y is always 0. Okay, so do those three transformations. Okay, so we translated this up 2 units into the right 5. Now we're reflecting this across the y equals 0 line. Remember, this is y equals 0, not the y-axis. This is the y-axis. This is y equals 0. So the C stays the same. This is up 3, so this is down 3. And that's E prime. And then D is up 1, 2, 3, 4 from there, so it's going to be down 1, 2, 3, 4. And that's D prime. So it should look like this. Any questions over that? Okay, the rotation we're struggling with the most. We want to graph 0, 2 first. So I'm going to go where X is 0 and Y is 2, which is right here. And I'm going to rotate that 180 degrees. Okay, so remember when we did this, I would like do a hinge. So from my point that I'm rotating about, I draw a line and I just let it fall 180 degrees. So D is now going to be down this way. It was up 2 and now it's going to go down 2 because I'm rotating it this way 180 degrees. This is my now new D prime. I do the same thing with E. Okay, I'm going to draw a hinge to it. So I'm just going to go to the left however many and up however many. And then I'm going to rotate that hinge around 180 degrees. So picture it just moving this L shape around all over here, 180 degrees. Okay, so that hinge, when I rotated it, would go over 3 and down 1. And that would be my E prime. Finally, I'm going to do the same thing with the C from my point that I'm rotating over and down. And my hinge is going to rotate. Take this L and rotate it 180 degrees. So it'd be over 4 and up 2. So over 4 and up 1, 2. And that would be my C prime. So this would be my triangle. If I rotated about that point. Any questions over that? Okay. Okay, your homework is the 6.2 homework in your packet. You guys can start working on that.